So here's just a quick overview for the unit. And the first thing is that when you are doing a test, you're going to do a right-tailed, a left-tailed, or a two-tailed test. This actually is 12D. This is the third thing. Let's start down here, actually. So the first thing is writing your null or alternate hypotheses. Remember, the null always has an equals as part of it. So it can either be the mean is equal to some number, and I'm writing mu sub 0 because when you do a stat test, the mu sub 0 right here is whatever's from your alternate hypothesis. So the null could be equals, less than or equal to, or greater than or equal to, and then the alternate could be not equals, greater, or less than, and these go together. So, and these go together, and these go together. So when you make a claim, for example, whichever one it is, the null or the alternate, then you automatically should know what the other one is that goes with it. So then for 12D, like we said, once you have written your hypotheses, you look always at the alternate to see whether you have a right-tailed test, a left-tailed test, or a two-tailed test. So let's take a look at these one at a time. Remember that if it's greater than, if your mean or your average, your population average is greater than some number, it's your alternate hypothesis, that's like a right arrow. So this part of the inequality is like this part of the arrow pointing to the right. That means all of your alpha is on the right for your critical region. And remember that we use inverse norm to find our critical value. It's important to put in that critical value because then once you actually do the test and your calculator gives you some z-score or t-score, then you'll know where on this curve to put it. And that's important because in the critical region, we are critical of the null and we will reject the null. In the non-critical region, that's the region where the null is okay. We're not going to reject the null. Okay. So then if the average is less, that gives you a left-tailed test and all of your alpha is over here on the left for your critical region. You're still going to use inverse norm to find that critical value, and everything to the right of it is the null is okay. And then for not equals to, this guy does not look like an arrow at all. So we'll use a two-tailed test. We will split our alpha into two. So this is not the same as the confidence interval drawing that you do. So you have two critical values, but they're the same as each other. You would use inverse norm for one of them, and this one is a negative, and this is a positive, but they're the same value because it's exactly split. And then the other thing you'll look at is your p-value. Remember, the p-value really, this p is for probability. It just is like the probability that we should reject or not reject our null hypothesis. So that p-value has to be between 0 and 1. If you get a number that is like 3.7, keep going, look to the end of the decimal because you might have an e. Oh, sorry, between 0 and 1. You might have an e, which means times 10 to the whatever. Okay, so you're still going to compare the p to the alpha, just like we did before. If the p is high, the null can fly, and we don't reject the null. If the p is low, the null must go, and we do reject the null. And we're still going to draw the z or t-score into the curve, and it should agree with whether the p is high or low. Okay. So you can look at the next video for some actual examples.